Right now, you are sitting still, or at least that is what your body is telling you. But every single thing your senses are reporting to you in this moment is wrong. Not slightly wrong, not approximately wrong, but fundamentally, completely wrong in ways that took humanity thousands of years and some of the greatest minds who ever lived to even begin to understand. Space does not work the way you think it does. And the strangest part is not any single discovery. The strangest part is how many things you believe about the universe right now, things that feel obvious, things that feel like common sense, are nothing more than illusions your brain constructed to help you survive on one small rock, in one quiet corner of a cosmos that follows rules your intuition was never built to grasp. Start with something simple: motion. You feel still. But right now, the surface of the Earth is spinning at roughly 1,670 kilometers per hour at the equator. At the same time, Earth is hurtling around the Sun at about 100 to 7,000 kilometers per hour. The Sun itself is orbiting the center of the Milky Way at around 828,000 kilometers per hour, and the entire Milky Way galaxy is moving through space at roughly 2.1 million kilometers per hour relative to the cosmic microwave background, the faint afterglow of the Big Bang. You are not sitting still. You have never sat still, not once in your life, and yet you feel nothing because motion on its own is undetectable. You can only feel changes in motion. This is something the Italian astronomer Galileo Galilei grasped in the early 1600s, that a person riding in a smoothly moving ship below deck with no windows could not perform any experiment that would tell them whether they were moving or standing still. He called it the principle of relativity, and for centuries scientists assumed it was a curiosity, a quirk of mechanics. They had no idea it was a doorway into the deepest strangeness the universe contains, because in 1905, a 26-year-old Patenclerk in Bern, Switzerland, took Galileo's insight and pushed it to its logical extreme. His name was Albert Einstein, and what he found when he pushed it was not what anyone expected. If motion is relative, if there is no universal frame of reference that is truly stationary, then what is the same for every observer, everywhere, no matter how fast they are moving? Einstein's answer changed everything. The speed of light. Light travels at approximately 299,792 kilometers per second in a vacuum. And unlike everything else, unlike sound, unlike the speed of a thrown ball, the speed of light does not add or subtract based on how fast the source or the observer is moving. You can be traveling toward a flashlight at half the speed of light. The light will still arrive at you at the full speed of light. You can be racing away from it. Same result. This is not intuitive. This should not work. And yet every experiment ever performed confirms it without exception. But here is where things get genuinely strange. If the speed of light is constant for everyone, then time cannot be. Time itself must bend. A clock moving very fast through space ticks slower than a clock standing still, not because of any malfunction, not because of any mechanical effect, because time itself is flowing more slowly for the moving clock. This is called time dilation, and it is not theoretical. It is measured every single day. The GPS satellites orbiting Earth right now are moving fast enough that their onboard clocks run slightly slower than clocks on the ground. Engineers must correct for this difference constantly. Without that correction, GPS would drift by several kilometers per day within weeks. Your phone knows where you are, partly because Einstein understood that time is not a fixed river flowing at the same rate for everyone. Time is personal. Time is relative. Time depends on how fast you are moving and how strong the gravity is around you. And gravity is the next place where your intuitions collapse entirely. You probably think of gravity as a force, a pull, something that reaches out across space and tugs objects toward each other. This is how Isaac Newton described it in 1687, and for over 2 centuries, his description was the most accurate model of the physical world humanity had ever built. It predicted planetary orbits with breathtaking precision. It explained the tides. It allowed scientists to calculate the existence of Neptune before anyone had ever pointed a telescope at it. But Newton himself was uneasy. He wrote that the idea of gravity acting instantaneously across vast distances of empty space without any medium to carry it was so absurd that he believed no thinking thinking person should accept it. He offered no explanation for why gravity worked. He only described how. Einstein replaced the force with something stranger and somehow more beautiful. Gravity, in his theory of general relativity, published in 1915, is not a force. It is a curvature. Space and time, a fixed background stage on which the universe performs. At all. It is a curvature. Space and time are not a fixed background stage on which the universe performs. Space and time are themselves physical things, and massive objects bend them. Imagine a stretched rubber sheet. Place a heavy ball in the center. The sheet dips. Now roll a marble nearby. It curves toward the heavy ball not because the ball is pulling it, but because the sheet itself has been warped. Every object moving through space is following the curves that mass has carved into the fabric of space-time itself, and light follows those curves too. During the solar eclipse of 1919, the British astronomer Arthur Eddington traveled to the island of Principe off the coast of Africa to test Einstein's prediction that light from distant stars would bend as it passed close to the sun. The stars appeared to be in slightly different positions than they should have been because the sun's gravity was bending their light around it. Eddington's measurements confirmed Einstein's equations to remarkable accuracy. The news made front pages around the world, and Newton's view of gravity, adequate for over 2 centuries, was quietly set aside. But space becomes stranger still. If you travel far enough in any direction, trillions and trillions of light years, you will hit a horizon, not a wall, not an edge with something on the other side. A horizon beyond which, even in principle, no information can ever reach you. Because the universe is expanding, and beyond a certain distance, space is expanding faster than light can travel across it. This is not space moving into something. There is no something outside of space for it to move into. Space itself is growing. The distance between galaxies is increasing, not because galaxies are flying through space away from each other, but because the space between them is stretching. The Belgian physicist Georges Lemaitre first proposed this idea in the late 1920s, and when Edwin Hubble confirmed through observation that galaxies were indeed receding in all directions, the picture that emerged was revolutionary. Run the expansion backward in time, and everything converges. All matter, all energy, all space itself, compressed into a state of unimaginable density, a beginning, the Big Bang. And yet, even the Big Bang is not what your intuition probably pictures. It was not an explosion in space. It was an explosion of space. There was no single point where it happened. Every point in the universe was that beginning. The center of the Big Bang is everywhere, including exactly where you are sitting right now. The cosmologist Carl Sagan once said that the cosmos is all that is, or ever was, or ever will be. But what science has revealed is that even that statement carries surprises. The observable universe, the sphere of space from which light has had time to reach us in the 13.8 billion years since the Big Bang, is vast, almost beyond comprehension. Around 93 billion light-years in diameter, but the full universe, the unobservable portion beyond our cosmic horizon, may be vastly larger still. Some models suggest it could be infinite, and here is something that stops most people cold when they really consider it. The light reaching your eyes right now from the Andromeda Galaxy left its source approximately 2.5 million years ago. You are not seeing Andromeda as it is. You are seeing a ghost, a 2.5 million year old photograph projected across the void. Every star you can see in the night sky with your naked eye is sending you ancient light, photons that left their source anywhere from 4 years to thousands of years before you were born, before your country existed, before the civilizations that built the first cities had been imagined. When you look at the night sky, you are not looking at the present. You are looking at many different paths, all layered together, all arriving at your eye in the same moment. And even the atoms in your body carry that history. The hydrogen that makes up most of the water in your cells was forged in the first 3 minutes after the Big Bang. The carbon in your DNA, the oxygen in your lungs, the iron in your blood, all forged in the cores of stars that died before the sun was born, scattered by supernovae across the galaxy, gathered by gravity into a new solar system. assembled by chemistry into a living world, evolved over billions of years into a mind capable of looking up and asking where it all came from. You are the universe trying to understand itself, and almost nothing about that universe works the way your daily experience suggests. Time bends, space curves, motion is relative, gravity is geometry. The present you experience is not a universal fact. It is a local one, shaped by your speed and your position in a gravitational field. The light you see is old. The ground you stand on is hurtling through space at speeds that would vaporize anything in its path. The universe had a beginning, and that beginning was everywhere at once. None of this is science fiction. All of it is confirmed, measured, tested, encoded into the technology that runs the modern world. Right now, you are sitting still, but the universe has never let anything stand still, not for a single instant, since the moment everything began.